hurricane. It was the first of the season, our fifth named storm of the season, Elsa, and it did so earlier than normal. Now, climatology, when we look back from 1966 to 2009, the satellite era, so far, again, it's got 10 more years ahead of that should be added on, and it will in due time. But in that average, the first date of the hurricane, first hurricane of the season, is right around August 10th. So we are way ahead of schedule. That developed, or became a hurricane, on July the 2nd. All right, here's how it looks on satellite imagery. Not the most impressive on the satellite. We're looking at the infrared imagery right now. What this does is it tells us the temperature of the cloud tops. So what we're looking for cold cloud tops, strong thunderstorm activity, is the shades of black and white. You can certainly see that, but it's not completely encircling the center of the storm right now, and it's also weakened a bit, but not for the normal reasons you would expect. I'm going to break that down for you in just a second, but here's the stats on it. Winds at 70. The forward speed, which is playing a factor in its weakening, now down to 29 miles an hour. It was moving at 31 earlier, so a minuscule drop in that forward momentum and an increase in its pressure. It's up to 999 millibars right now. I want to show you the progression here, the evolution of this storm. This is a 24-hour loop of that same imagery. As it crossed into the Caribbean, it was much, much stronger. This is when it became a hurricane, a Category 1, topped out at winds of 85 miles an hour, caused some damage in places like Barbados with gusts over 90 miles an hour. Now things have weakened a bit, even though it is moving over an area that's very conducive for it to strengthen further. But there are reasons at play here that's prohibiting that. Here's a look at water vapor imagery. Dry air over moist air, okay? Very moist system, a tropical system. No dry air, which will be indicated by some rust color. Not seeing any of that. So we've got the moist environment. That's ingredient number one for tropical sustainment and development. We also have the very warm sea surface temperatures. The Caribbean Sea overall, well above where we need it to be, which is at least 80 degrees Fahrenheit. We are in the mid-80s there. So that's not a problem. There's plenty of fuel. Now, what else we look at is the wind shear. And wind shear is a change in direction and speed as you go higher up in the atmosphere. That's detrimental to a storm's growth because it blows the tops off of thunderstorms. It kind of dislocates the convection or thunderstorms away from the center. And what we're seeing here, areas here off that are shaded in green, are unfavorable, meaning higher wind shear. It's moving into an environment and located in an environment that wind shear is relatively low. Now that's environmentally. So let's go over quickly again what wind shear is. Vertically stacked engines is what a hurricane is. It needs to circulate and ventilate properly and circulate and bring that air up to aloft and kind of disperse vertically. We see that when there's no wind shear. When there is wind shear, it blows the tops of those thunderstorms off the top, tilts the system, and it cannot ventilate properly to sustain strength and organization. So what's going on? Why is it weakening? Well, it's actually self-inflicted wind shear. Wind shear coming in out of the northwest, that's the same direction it's moving. It's moving so quickly that the surface low is moving faster than what's aloft and it's tilting itself. Think of it this way. You're carrying a stack of boxes that goes really, really high, right? So when you're stationary or moving slowly, those boxes remain vertical, okay? That column of air, if you will, is vertical. If you start moving faster, you're moving fast and that pile of boxes begins to tilt a little bit. That's kind of exactly what's happening here. The surface low is scooting along very fast. The upper levels are tilting, self-inflicted, even though the overall environment conducive in terms of wind shear to keep it relatively put together. But if it continues moving this fast, it will continue to weaken. So here's how it looks. The latest forecast track from the Hurricane Center keeps it at a high-end tropical storm. 74 miles per hour or greater is a Category 1 hurricane. So we're at 70, high-end tropical storm, still a lot of winds, impacting southern portions of Haiti here within the next 12 hours. Overnight, it looks to track north of Jamaica and then potentially scoot along the south coast of Cuba. Now, as we get into early next week, this is when it could present a threat to Florida. At that point in time, slightly weaker, at least how it looks right now from the Hurricane Center. Winds at 65 miles an hour, looks to move right along the coast near Tampa and then slide north towards Jacksonville. Why is it turning north? Well, we've got a cold front that's affecting us here, driving those shower chances up for us here in Houston this weekend. That's actually going to help to shift that storm. It's going to get picked up with the winds and move it off to the north and eventually off to the north and east. So it's not going to be a problem for us, but we'll still have to watch it. Now, watches and warnings are up through much of the Caribbean. We've got the tropical storm warnings and hurricane warnings here, even for southern Dominican Republic and portions of Haiti as well. Now, how are the computer models seeing things? Spaghetti plots here. Each line is a different computer model and relatively good consistency close by, consensus I should say, but as you get farther out, you get that dispersion of all those models going in other directions. Now I want to show you something a little bit different. This is the GFS spaghetti plots, but we're showing the GFS ensembles. What is an ensemble? Well, it's the GFS model, but we tweak it a little bit and run it several different times. So these are the different scenarios here, and way out in time here, you get a spread of about 1,100 miles of where this could go. So that's why we have that cone of uncertainty. It's very narrow at the onset because there's good consensus in the models, and then there's diversion as you get farther aloft. That's why the cone grows, and there's higher uncertainty farther out in the cone. So we'll have to watch this. Still, the Gulf, at least the eastern Gulf, could be at play here, but certainly looks like along the west coast of Florida more and more likely. But the good news overall is that aside from Elsa, there's nothing else really going on in the tropical Atlantic right now. Things are relatively quiet, especially the main development region here out towards the east. So that's the good news for now. All right, you got a question? Don't be afraid to reach out on social media. I got all brand new accounts here on Twitter, Instagram, and on Facebook. We'll see you next time.